Assalamu alaikum wa rahmatullah. Welcome everyone to IE 342 Quality Control. And today's inshallah lecture we will talk about Chapter 3, Statistical Models for Quality Control and Improvement. This chapter is nothing but a quick revision of what you covered in Probability and Statistics course about the general distributions, that type of probability distributions, about statistics, characteristics, and parameters. We will cover some of the variation or descriptive variation and descriptive statistics tools. We will cover important discrete and continuous probability distributions. We will demonstrate also a quick overview how you conduct those on the Minitab. Requesting all of you to download the Minitab software, that you are going to use it along this semester in this course, as well as you have used it, or maybe if you have not taken the course 242, which is design of experiment, you are going to use it also in that course. So it is very important, and the website offers a rental version, so it is per semester or a month. So you can rent it for the duration of the semester, and you will be able to access all the features. So let's start with the descriptive variation, or the describing variation. Some of the tools, what we are going to do here is we are going to demonstrate the tool, what is the objective of the tool, and how you conduct it or how you do it on the Minitab. Those are the main tasks from you that you have to master it in this chapter. The first tool is Stem and Leaf. Stem and Leaf, as it says here in the slide, it is used to classify either discrete or continuous variables. A stem and leaf plot is used to organize data as they are collected. This is the stem and leaf representation here on the right side of the slide. It shows the leaf. If you imagine a plant, the stem usually is one, which is connected to the root, and the leaf, where is the plant have multiple leaves, not one. That's why you see the stem, it is only one here, and the leaf is considered to be those numbers. If you look or you turn this table horizontally, it will look like a bar chart or a histogram chart. So it will give you also the type of distribution of this data, if you imagine how the histogram was drawn from those numbers. We will show how those numbers comes now in a few. This part is not in the slides you have, so you will see some notes here. It is my notes that I would like from you to write it and type it down in your copy, so you can understand what is the tool is used for and what it does. So it does organize the data as they are collected, and it works for both discrete or continuous variables. Most of you definitely should know what is the discrete and continuous variables. Discrete is representing like counts, and continuous representing like measures, measurements like length and width and so on. How we do the stem and leaf on the Minitab, I will demonstrate that to you now on the Minitab. I will share with you the screen and demonstrate it to you. now the screen shared with you to show you. This is the Minitab, and this is the worksheet. It's similar to the Excel. I have put some of the data on the table that you have here on C1 and C2. Can you hear me? Just to make sure the voice is heard. Can you hear me? Can you see the screen? Okay, good. Okay. The claim and the days, where you have the option to do the stem and leaf, you go to graph, and then you go to stem and leaf diagram, and you select the columns where is the data, claim, days. I put them on. When you do OK, then the stem and leaf will be drawn here. What is this data represent? Or how we can read or how we can elaborate or interpret the stem and leaf diagram. For example, here we have, let's start with the first one here. This is the stem, which is 2, and the leaf is 6. Where is that in the data? This represents the 10th digit in the data. We have the data contains of 2 digits, tens and ones. أحاد عشرات. The tens they are here, the one on the left. 5 in the 52, 4 in the 48, 41, and so on. Okay. So the first one was showing that 2. So we go to the digit 2, whereas the 26, the 10th represent the 2, and the 6 represent the 1. The count is ones, because there is only one count for the leaf, which is the 6. On the other example here, we have the 3. 3 here, it has 5, 6, 6, 6, and 7. Where those come from? Again, this is the 10th digit, which is the 3. We see it here. The first time appears is 35. So you see the 5 taken into account of the leaf. The second leaf is from the second 36, and the third leaf was taken also from the third, which is the 36, and also the other 36. That's why you see the 3 or triple sixes. Then the 7, which is the one comes from the 37. Those are the numbers associated with the stem 3. And the count is 5 because the number of counts for the leaves are 5. Other one is the stem 4, which is here. We have it 41 and 48. You see 40 and 1 is the count for the 41, and 48 is count for the 48. Representing the data either this way or in this way, it is an option, but it doesn't matter. You can also put the 4, 8, and you put the count is 2. As you can do it, this is one of the options in the representation. 5, it is also appeared on the first number, whereas the 10th digit is 5 and the 1st digit was 2. Basically, to show that the distribution, how it looks like, if we flip it to horizontally and see how it is look like. Now, let's continue with the slides. Plot data in a time order. This is similar to the run chart that we have covered in the make. Also, they call it the marginal plot. It helps relation between two variables and examine their distribution, because also you can see here on the right side of the figure, you can see how the distribution look like And this is an optional. You can ask the Minitab to do it for you, or you can use only the run chart or the plot data in the vertical and the horizontal axes to show the relation between the two variables, whether there is a correlation, there is linearity, and so on. Also, this can be produced by the Minitab, and I will show you how we do it now on the software. Okay, now I'm sharing the screen with you of the Minitab. Again, back to our data. This is how the marginal plot looks like, and you see how is the margin that on the right side shows the data. Again, this is a sample data from the given in the slide. You can implement and try having all the data, and it will give you the same figure as in the slides presented. To find the marginal plot, you go under graph and you select marginal plot. There are three types. You can use either the one represented on the slide was the one with the dot plots, and you choose the variable for the y-axis and the variable for the x-axis, and you press you press OK, and then it will show you how the relation between the claim and the number of days. The days here are the number of counts, and the day are the sequence of time. Now this is depend on the nature of the data, and the marginal plot shows the density, how it is represented in terms of similar to histogram, and shows similar how the distribution will look alike. The third, I will stop sharing now the screen, and let's go back to our slides. The histogram useful for the large data. Now, the histogram, it was mentioned in the previous tools when we talked about stem and leaf. We said if you flip this to horizontally, you will see a histogram shape. Also here in the plot data. Here, where is the histogram tool is presented, the histogram used to show the count of number of observations, also the plot the frequency of the data and the values. You are familiar with the histogram, how it looks like. These are the thickness of a metal data measurements, and here is the frequency. For example, the 435 thickness counted for, let's say, out of 20, it was 18 approximately. And also that can be presented from the Minitab. Under the graph, you can choose the same data we have presented previously using a histogram instead of the plot or the dot plot or the stem and leaf. The additional figures you can, or graphs, you can use it on the under the histogram. You can select the type of the histogram, whether cumulative or only the histogram without a cumulative option. The cumulative is adding all together and have in a cumulative format to show you something similar to the Pareto, even though also the Minitab shows the Pareto option, which I will also demonstrate it to you, inshallah, after we go back to the Minitab today. The other descriptive parameters is the mean or the average, and the average is commonly used in the quality control because we use it for drawing the control charts, We use it for doing hypothesis tests and so on. The average or the arithmetic mean use the abbreviation X bar, and the average of the metal thickness for that example was presented in that example. There is an important note. Also, we will show you in the Minitab how we do the calculating the average. There is an important note here. It says sample variance is simply the sum of the squared deviation of each observation from the sample average. So what is the difference between the variance and the standard deviation? There is a note that I posted on here. I will show it to you just in a few. Hold on. We will go back to our slides, but I would like to draw the attention to this note. The variance measure the average degree here on the right. I put this note here so you can screenshot this slide if you want, or you can write it down. The variance measure the average degree to which each point differ from the mean. So the average that give you the difference between each point from the mean. The average of the readings for each one of them, how it is differ from the mean. Whereas the standard deviation, how the spread. See, here is the average degree. Here is the spread out of a group of numbers from the mean. So here deals with the group, and here deal with the average of each reading. The average of each reading, the collection or the collecting data, but the average of each one of them here deals with the group as a sum, how they are differ from the mean. This is very important, and it is very crucial to understand the difference between the variance and standard deviation, because here, as it shows the formula of the variance, and here deviation, but you need to know what is the meaning out of those parameters. You don't have to memorize the formula. I'm not going to ask you to memorize it. I'm going to ask you to implement it and know what is the meaning out of it. So here is the definition of the standard deviation with the formula of the standard deviation. The other tool that we have in our chapter today is the box plot. They call it also box and whisker plot. The box plot, which is presented here on the left side of the slide, it is visually show the distribution of an data and the skewness through displaying the data quartiles or percentiles and average. The numerical representation you see here, usually numbers on the sides, as well as in the box, where is the mean or the median, to be accurate, is presented. The median is usually written here in the middle of the box, and the quartiles, al-arba', the Q3 and Q1, which is representing the 75th percentile of the data, and the 25th percentile of the data as a Q1. And here is the maximum and the minimum, which is the Q1 minus 1.5 multiplied with the QR, which is the range, to show that the skew of the data, whether it is moving towards the minimum or it is moving towards the maximum. This is a representation here, another demonstration, where the numbers are presented. Here are the quartiles, the maximum and the minimum. Here is the median, and here is the Q3, which is the 75% of the data collected readings, and here is the 25% of the data comes under the 120. And here is the minimum quartile of the data and the maximum quartile of the data. And here are the data was given. So if you use these data and you apply it on the Minitab, you can get this figure and presented. We will see also now how we can use the Minitab to present the data using the box plot. So let's share the screen again. Here is the Minitab again, and under the graph also, as we have talked earlier, you can do the histogram here. You can use it with the fit of the distribution to see how the distribution of the data, whether normal or other distributions. Here you can choose the data you would like to present it in the histogram. I choose the metal thickness as an example, and here is the histogram. If you would like to use the box plot, also you can use the graph section. Under the graph, you can use the box plot. You can choose the simple, or if you have a comparative box plot data or groups you would like to compare among them. And to demonstrate that, you choose for example, here I choose the metal thickness again, and representing that in the box, and it shows you the median. If you go with the pointer, it will demonstrate the data automatically, or also you can use in the labels to have them written on the figure. You have the Q1 and the Q3, which is the quartile 1, the quartile 3. The median is 450. All this what you need to know and how to do it. When you use the box plot, you have always recall why we use those tools and how we do them on the let me stop sharing now, go back to our slides, how we do them on the Minitab. The other box plot that I told you about, if you have groups and you would like to compare, for example, between them, for example, here a comparative box plot of a quality index for products produced by 3 plants. If you have 3 different plants producing, for example, the same product, and you would like to compare the quality between them, and you have a quality index for the product. The index is a numerical representation for different quality variables or factors like reliability, durability, and so on that we have talked about in the first lecture. You can convert them in formulation to have one number representing the quality for that product. So if you have taken samples from these different plants and you use the box plot, it shows you how the median for each plant and the quartiles for the plant in terms of the quality index. So you can have a comparative visually between the quality index for the 3 products or for the products that comes from the 3 different plants. So this is one of the use of the quality tool. Again, here is this note is not given in the slides, so you write it down. Visually show the distribution of numerical data and the skewness through displaying the data quartiles or percentile, nisbat or nisbat al-data and percentiles of the data. So 75% or 25% of the data. The probability distribution, and this is also covered in the statistics, What you need to know is definition here. A probability distribution is a mathematical model. So it is a mathematical formulation. It's not a graphical demonstration like what we did before in the other tools. It is a mathematical model, relates the value of the variable with the probability of occurrence of the value in the population. So it is a mathematical model. It shows the relation and it relates the variable between each other, as well as it shows you the probability of occurrence. That means the chance of the occurrence in the population في not the sample اللي هو التعداد الكامل. Sample it is عينة التعداد الكامل اللي هو population. So the chance of occurring that value it will be shown in the probability distribution. So what we need to know, it is a relates the value of the variable with the probability of occurrence. So if to understand or to know or to predict the chances of the rain that will appear tomorrow, for example, in Medina region or in Riyadh region, you have a probability distribution which is usually based on historical data. Then it turns to a mathematical formulation to choose or to see based on the historical data what was the type of the probability distribution, or what is the type of the distribution we have for the historical data. Then we can generate the mathematical model. This is forecasting based on the historical data. It is different also than the people specialized in the weather specialty, who are tracking the winds and the position of the earth compared to the distance in the summer and the winter with the sun and so on. That is another field, but we are talking based on statistics. You can use historical data to generate the distribution and see what type of distribution, and from that type you can go with the mathematical model that can give you the prediction of the occurrence in the future. We have different two types of distributions. We have the continuous distributions and we have the discrete distributions. The continuous distributions, the variable being measured on a continuous scale, as we said, like height, length, and so on. Discrete distributions are that integer numbers like counts, number of people, and so on. Here are samples of the continuous distribution on the right side and a discrete distribution, how it looks like on the left side. The formulation for the or example for the discrete distribution is given for a manufacturing process produce thousands of semiconductor chips per day on the average of 1%. Of these chips don't confirm the specification. So 1% of these chips is not meeting the specification, so it is non-confirming the specifications or considered to be a defect. Every hour, an inspector selects random sample of 25, so the sample size is 25, and classify each chip in the sample as confirming or non-confirming. If we let X be the random variable representing the number of non-confirming chips, then the probability distribution of X is given as it shows here. So we have the sample size. This is the demonstration of the discrete distribution probability. We have the sample size, and we have X, which is the random variable. and the probability of occurrence is given because it is 1%, then you multiply it with the subtraction of the 100 to the probability of occurrence of the sample size minus the number of variable. All these can be done automated using Minitab and tables that gives you the answer without doing the calculation. So you are not requested to implement it mathematically manually on hand. The reason of showing the example here is to show that the distribution here, if it is discrete, the values of the variable will be considered to be count and numbers, and the probability of occurrence is the representation of the probability distribution because it shows the chances of occurrence of the defects based on the percentage of the historical data and the sample size was selected. Now for the continuous distribution, about the sample size, you may have a question how we find the exact number of sample size to be chosen from a population. That is going to be discussed in a separate chapter, inshallah. For the continuous distribution, again, there is an example, shows you how the continuous distribution is being calculated and found. There are different types of distributions going to be discussed today, and we will go over them very quickly just to know there are different types of distributions among the discrete and the continuous. Here we are going to just quickly go back to the mean, and the mean is the point which the distribution exactly balance. There are different three variables that represent the central tendency, mean, mode, and median. You have to know and distinguish the difference between them because it is very important to know what is the difference between mu, which is the mean, and the median and the mode. And the difference is very easily described here. The mean doesn't have to be the 50th percentile of the distribution because that is the median. The median comes in the middle, regardless of the actual balance between the data, whereas the mean shows the actual balance between the data, and it doesn't have to be in the middle, as you can see here. Whereas the data skewed to the left, the mean was not centralized, but the median was always and is going to be always in the center. This is whereas usually the mean and the median, they come together at the same point when the data are centralized in terms of the readings. The mode is different. It is the most likely value appear in the data. So the value that appeared more frequent in the data represent all these being covered in the statistics, but this is just a quick review. Here was the difference between the variance and the standard deviation. The distributions, again, going back to the type of distributions, we have the hypergeometric distribution, and this is the formula. You don't have to recall the formula. You just need to know some of the distributions under the discrete data, which is the hypergeometric is one of them. We have what is the use of that hypergeometric? Usually it is used for selecting the random sample. So when we come to the chapter to find what is the sample size or what is the sample plan for the production, you use a hypergeometric to help you to find what is the sample size. So you need to know the type of it's a discrete or a continuous, and what is used for. That's all what you need to know. You don't have to recall these formulas. This is just for refreshing your statistics. The other type we have is the binomial, and the binomial also called or brought from or based of the Bernoulli trials, and the binomial used here, it shows you here the binomialist distribution is used for the inequality engineering. It is appropriate probability model for sampling from infinitely large population. So when you have a large population, you have you can use the binomial distribution, and for the continuous, I believe we will have it in a few after showing then representation or the graph representation of how the binomial look like. And all these can be done on the Minitab, and I will show you in a few how we do it. The Poisson distribution is used for counting the data. It is a good use for counting data. Another distribution is we have the negative binomial. They call it also the Pascal. If you here with familiar with that name, and the Pascal also sorry, the negative distribution, they call it also the geometric distribution. The negative binomial called the geometric, and also it called the Pascal, but the geometric is the one here in demonstrated in the slides. The Pascal, it is maybe was common in the statistics course, but is not well known here to be used with that name. The geometric distribution useful for the number of failures before the first success. So when you do the run test or the burnout test that we have talked about in the reliability when we talked the first chapter, you use the geometric distribution to see the number of failure before you launch your product, as they say in the beta test. And here is where is the idea of beta test comes from the geometric distribution is one of the tools that used to conduct the beta test. Let's go back again to the Minitab to show you if you would like to see the data you have on which distribution they look like, to see how they will look like. Let's see on the Minitab how we can do that. Okay. Oh yes, here is one point that I would like to show it to you before the. When you go and use the descriptive statistics, let's say we have used the metal thickness data, you can select here on the statistics and choose all parameters that you would like to calculate. For example, I've chosen here, I check the mean, standard deviation, the variance, because it's the commonly used. You can also here find the box plot parameter, which is the first quartile, median, third quartile, as well as the range. For the graphs, also you can use or select histogram to be drawing, histogram with the normal curve to check the normality of the data, as well as the box plot. You can choose it to be in the data, in the result. So when you press OK, it will give you the answer here. So this is the mean, the standard deviation, and the variance for the given data. And here is the histogram with the normal distribution to show you how whether the histogram representing normal distribution or no. For other tools here, you can use the probability distribution plot, and that will show you the, if you have, for example, mean, standard deviation, and sample size, it will show you whether how data will look like in terms of the type of distribution. I choose here the hypogeometric use just a random here data. I will post, and to show this is the hypergeometric. You can also select any other distribution like from what we covered today, the binomial, and you can put the number of trials, the probability, and that will calculate or will do uh, the calculations for you. So you don't have to um, do the calculations from the formula. That's why I ask you to don't recall those formulas. All what you need to know is the parameters that needed for each one of them to be calculated or to be found in the distribution. For example, like we had here in the hypergeometric, if you have the mean, the standard deviation, sample size, all that, if you have those variables, and the Minitab the distribution for you. I will leave now the time for questions. That's all for now. We'll see you in the next video.